There's something strange that happens when you look up at the night sky. You don't just see stars, you see time itself. Light that began its journey long before you were born, long before there were cities, long before even the first humans took a breath. And yet here it is, slipping quietly into your eyes tonight. The question, though, is one that's as old as wonder itself. How far can we really see? Is there a wall, an invisible limit, where the night stops revealing and starts keeping its secrets? Tonight we'll walk through that question gently, like a wanderer crossing a field under starlight. A quiet moment under the night sky. There's a stillness that only arrives when the world is half asleep. The streets are quiet, the air feels cooler, and above you, a black ocean scattered with small, trembling lights. It's in moments like this that the mind forgets about noise, about lists, about the heavy pace of the day, and instead begins to wonder, what am I really looking at? You're not just glancing upward, you're meeting something that has been shining for thousands, even millions of years, and only now has its light found you. When you stand there long enough, the idea of distance starts to shift. It's no longer about kilometers or miles. It's about time. Each star becomes a frozen signal from the past, arriving just in this instant, as if the universe planned a meeting with you and kept it exactly on schedule. And the more you think about it, the more your breath slows, because your eyes are catching pieces of history without even moving a step. The breeze might pass, a faint hum of the world might return, but your gaze doesn't break. There's something about standing in the quiet under stars that reminds you how small and yet how connected you are. You could close your eyes and still feel the presence of that light above you, as though the night itself is pressing gently on your skin. And in that moment, you realize the act of seeing is not just sight, it's a conversation. The stars are not silent, they are speaking in the language of photons, in the dialect of patience. If you could answer them, maybe you'd say, I see you. And perhaps in some way they'd see you too. Somewhere in that stillness, the question takes shape again. Just how far is my eye reaching right now? Is it a few light years, or something far more unimaginable? The night doesn't answer yet. It only invites you to keep looking. The feeling of distance in the stars above. Distance in space is not like distance on Earth. On a road, you can count signs or measure in steps. But above your head, distance stretches beyond any familiar scale. A bright star might be 10 light years away, while a fainter one could be thousands. Yet both fit within the same frame of your vision. That's the trick of the night sky. It hides vastness inside simplicity. The more you think about it, the stranger it becomes. That star you see tonight might have sent its light before pyramids were built, before languages were written, before your entire family line even began. And still, your small human eye, just a small patch of curved tissue, can catch it in a fraction of a second. When you really let that sink in, the idea of far changes shape. It's no longer just a number, it's a living story. You're not measuring the distance between 2 points. You're measuring the patience of light itself. And patience on this scale feels almost infinite. It's humbling to think that your body, built for walking and touching and hearing the nearby world, is also equipped to glimpse things that exist unimaginably far away. In a way, your eye is a tiny observatory, open every night without charge, ready to receive what the universe offers. And perhaps that's the quiet miracle. Without any telescope, without any machine, your vision alone is already a bridge across time and space. And somewhere ahead, we'll see how far that bridge can truly go. Light as a silent traveller through time. Light is never in a hurry, yet it never stops moving. It leaves its source, whether that's a glowing star or a distant galaxy, and begins its journey at the fastest speed the universe allows. No rest, no pause, just steady travel through the void until, perhaps, it finds a pair of eyes like yours. The amazing part is that light doesn't bring just itself, it brings stories. The faint glow from a star carries information about its color, its temperature, its age, and the space it crossed. It's a postcard sent millions of years ago, finally delivered tonight. And unlike sound or smell, light doesn't fade away in the same way as it travels. It can cross interstellar emptiness and still be caught by your eye if your gaze is patient enough. Even now, as you read this, some photons hitting your retina might have been traveling longer than humans have existed. It's a strange partnership, really. Your eyes are the receiving end of a cosmic delivery system that has been running since the first stars lit the universe. You don't have to know the physics to feel its poetry. And maybe that's why stargazing is so calming, because in that still moment, you're not just seeing light. You're hosting it, holding it for a second before it moves on, like a traveller stopping briefly at your door. How your eyes collect whispers from the universe. Your eyes are built like tiny, wet windows, but they're also sensitive collectors of the universe's oldest currency, light. Each time you look up, you're opening two delicate instruments to the night, and they catch whatever falls in. Most of the time, it's bright things, the moon, a planet, a handful of bold stars. But if you let them adjust, they begin to pick up whispers. These whispers are faint stars barely above the threshold of visibility. To the untrained glance, they're invisible. But with patience, and maybe a touch of stillness, your eyes begin to notice them. Points of light so soft that they seem to appear from nowhere. The rods in your retina, which work better in dim light, start doing the heavy lifting. They're the ones that turn near darkness into something you can navigate. And in stargazing, they're your allies, picking out the smallest glimmers from the cosmic background. You might not feel it happening, but in those moments, your eyes are reaching farther into space than they do at any other time. And the boundary of that reach isn't fixed. It changes with conditions, with the purity of the air, with how still you can hold your gaze. And as those faint glimmers gather in your vision, you realize you're seeing things that existed before your world even had the shape it does now. You're looking into the past without even trying. The faintest flicker we can still notice. There's a line, a fragile one, between what we can see and what we can't. It's not sharp like a cliff edge. It's more like a fading shoreline where the waves become too small to notice. That line is where the faintest stars live. They send enough light to just barely register in your vision, but only if you look in the right way. Astronomers sometimes measure this limit in magnitudes, a scale that describes how bright something appears to us. Under perfect conditions, a healthy human eye can spot stars down to about magnitude 6 or 7, which means light that is thousands of times fainter than what you'd see from a city. But what's fascinating is that this limit is flexible. A person who knows how to use averted vision, looking slightly to the side of an object rather than directly at it, can sometimes push the limit further, catching glimmers most people would miss. It's like unlocking a hidden mode in your own eyesight. And when you find one of those faint flickers, it's not just a dot in the dark, it's a presence. It's a reminder that even at the very edge of your vision's reach, the universe is still sending something, still willing to be seen. In a way, the faintest star you can see is the farthest personal handshake the cosmos offers you without any help from machines. And ahead in this video, we'll step quietly beyond that edge and see what happens when your sight meets the true scale of space. Darkness that is never truly empty. When you first glance at the night sky, it's easy to think of the spaces between stars as nothingness. Black, blank, silent. But the truth is that darkness is never truly empty. Even in the quietest patch of sky, there's light too faint for your eyes to catch, and objects so far away that their glow has thinned into invisibility. It's a strange comfort to realize that what looks like nothing is actually overflowing with presence. Every shadow in the sky is just light that hasn't reached your threshold yet. The universe doesn't make empty, it just makes more than we can handle at once. And yet, in those dark gaps, your imagination takes over. You start to wonder what's hidden there. Distant galaxies, drifting clouds of gas, maybe even stars whose light hasn't yet finished its journey toward us. You can't see them now, but the thought of them lingers, like knowing there's music in the next room, just too soft to hear. It's moments like these that remind you, vision is as much about trust as it is about sight. You trust that there's more beyond the darkness, even if your eyes can't prove it tonight. And so you keep looking, because part of the joy is knowing there's always more than you can see. The invisible river of photons. All around you, all the time, there's an invisible river flowing. Not of water, but of photons. Tiny packets of light streaming in from every direction. During the day, this river roars and blazes with the sun's brilliance. At night, it slows into a soft current fed by countless stars and galaxies. Every photon you catch from a distant star has been travelling an unbroken path since it left its home. It might have dodged planets, skimmed past other stars, slipped through clouds of cosmic dust, and yet it still finds its way to you. In that sense, stargazing is just dipping your eyes into this river and letting a few drops wash over you. You never feel them arrive, of course. They don't knock, they don't land with a weight, but they enter your eyes all the same, where they're transformed into tiny electrical signals your brain turns into vision. And just like that, the light becomes a part of you. There's something poetic about the idea that right now you're holding ancient light in your mind. You'll forget the exact shapes later, but for a moment, you and the universe are exchanging a gift. One gives, the other receives. And maybe this is why the night sky feels alive, because it's never still. Even in the deepest calm, the river is still flowing. How starlight bends around the Earth's breath. When starlight reaches our planet, it meets something it hasn't encountered in the emptiness of space, our atmosphere. This thin, shifting shell of air acts like a lens, bending and scattering the light in ways our eyes can see. It's why stars seem to twinkle. Their light is being refracted by tiny movements of air. On some nights, the air is restless, full of currents and temperature shifts. The stars shimmer and flicker like candle flames in the wind. On other nights, when the air is steady, their light seems sharper, steadier, more certain. Astronomers call this seeing, a measure of how clearly the sky will reveal itself. If you've ever watched a star and felt it almost pulse in brightness, you've seen the breath of Earth in action. That light left its source unchanged, but in its final moments of travel, it danced through an invisible ocean before reaching your eye. It's humbling to think that our planet doesn't just receive light, it shapes it, distorts it, sometimes hides it, and yet, in that distortion, there's beauty. Twinkling isn't an imperfection, it's a reminder that between us and the stars lies a living, breathing world. And for some reason, knowing that makes the stars feel a little closer. Why space looks sharper on mountain tops. If you've ever stood on a high mountain under a clear sky, you'll know that the stars seem somehow different, brighter, crisper. The air feels cleaner, the sky feels deeper. And that's not just your imagination, it's the effect of seeing through less atmosphere. Down at sea level, starlight has to pass through a thicker layer of air, picking up more distortion and scattering. On a mountain, you're above much of that interference. The photons arrive more directly, with less turbulence to twist them along the way. That's why some of the world's most powerful telescopes are placed on remote, high peaks, where the air is thin, dry, and steady. From there, the view stretches farther, not because space has changed, but because the pathway to your eyes is clearer. It's a little like looking through water. The deeper you are, the more particles are in the way. Climb higher and the view becomes sharper, more honest. The stars don't have to fight so hard to reach you. And when you experience that kind of clarity, it's hard to go back. The sky at lower altitudes feels softer, hazier, still beautiful, but a little more veiled. The colour limits of our vision. Our eyes can do many things, but in the dark, they surrender one of their most vivid abilities, seeing colour. Under bright light, cones in our retina give us rich reds, deep blues, and glowing greens. But at night, those cones step back and rods take over. And rods are better at detecting faint light, but almost blind to colour. That's why the stars you see often appear white or pale blue, even though many are actually rich oranges, yellows, and reds. Your eyes simply don't have the light to unlock those shades. It's not that they aren't there, it's that your vision has quietly shifted into survival mode, choosing sensitivity over vibrancy. Every so often, though, a bright enough star or planet will push through, showing its colour even to the naked eye. Mars with its rusty glow, Betelgeuse with its warm orange, Sirius with its icy blue-white. These rare bursts of colour feel almost like secrets being shared, and in that moment you realise your eyes are not just looking, they're adapting, negotiating with the night, deciding what to keep and what to let fade. That quiet exchange between you and the sky is part of the reason stargazing feels so intimate. Because the truth is, you're not seeing the universe exactly as it is. You're seeing the universe as your body allows it, and there's a beauty in that limit. When the night sky begins to fade into black, if you stand under a truly dark sky, far from cities, you'll notice something subtle. The stars don't stop where the black begins. They just fade. The human eye has a threshold, and beyond that, the light is too thin to spark a response. Past that point, the universe continues, but we stop receiving it. It's a little like listening to music from another room. At first, you can hear the melody clearly, but as you step away, the sound thins. The high notes vanish until only silence remains, even though the song is still playing. Astronomers sometimes talk about the limiting magnitude, the point where your eyes can no longer distinguish starlight from the background of night. For most people in good conditions, that's around magnitude 6 or 7. For others, with sharper eyes and patience, maybe a touch deeper. That invisible fade is humbling. It's not the end of space, it's just the end of your reach. And knowing that there's more out there than you can ever see with your own eyes makes the sky feel infinite. And perhaps that's part of the magic, that the universe always keeps something just out of sight. The way our pupils search for more light. In darkness, your eyes adapt in quiet, invisible ways. The most obvious, and yet rarely noticed, is the widening of your pupils. Like two slow, living lenses, they open wider to catch more of whatever light the night will give. This process takes time. The first few minutes in darkness reveal the brighter stars. After 15 or 20 minutes, more appear. Faint ones that were there all along but too weak to be noticed until now. It's almost like a secret negotiation between your body and the night. You give it patience. It gives you more stars. No rush, no force. Just a gradual unfolding of detail as your vision shifts into its nocturnal mode. You might even catch yourself leaning slightly forward, as if that could help you see farther. In a way, it's your whole posture trying to draw more of the universe in. And every time a new star appears where you swore there was only blackness, you feel that little thrill. The same one ancient skywatchers must have felt when they first learned the sky is deeper than it looks. Why some stars disappear in city skies. If you've ever compared the night sky in the countryside to the one above a city, you'll know it's not the same sky at all. Where once there were thousands of visible points, there may now be only a few dozen. This isn't because the stars have gone, it's because city light hides them. Street lamps, neon signs, headlights, all of them send light upward, scattering in the air and creating a glow called light pollution. This glow brightens the background of the sky, washing out the fainter stars, so they no longer stand out against it. It's strange to think that our own creations can erase so much of the universe from our sight. The stars are still shining, still sending light across unimaginable distances, but in a city, they might as well be invisible. For many people, this means the sky has never truly been dark. They've never seen the Milky Way as a river of light. They've never looked up and felt the dizzying weight of thousands of suns staring back. And yet the stars are patient. They'll wait as long as it takes for us to find darkness again. The quiet power of dark adaptation. There's a moment, if you spend enough time in darkness, when you suddenly realize you're seeing more than before. A shape you couldn't make out earlier is now clear. A star that wasn't there has quietly appeared. This is the gift of dark adaptation. Your eyes slowly tuning themselves to the night. It's not instant, and it can't be rushed. Full adaptation can take half an hour or more as your pupils widen and your rods fully awaken. Even the tiniest bit of bright light, a flashlight, a phone screen, can reset the process, sending you back to the start. It's almost a lesson in patience. If you want the deepest view of the universe, you have to slow down. You have to let your senses catch up to the stillness around you. Some stargazers wear red lights instead of white when moving in the dark, because red light affects night vision less. It's a small trick to protect those hard-earned adjustments. And when you finally stand in full dark adaptation, it's like stepping into another world, one where the stars multiply and the night feels fuller, more alive. How your eyes change shape in darkness. It's easy to think of your eyes as fixed structures, but they are living, moving, shifting things. In darkness, they don't just widen at the pupil. The lenses subtly adjust their curvature, the muscles relax differently, and the retina becomes more sensitive as chemicals regenerate within it. This process is mostly invisible to you, yet it's happening constantly as you move between light and dark. In bright conditions, your eyes are tuned for sharp, detailed color vision. In darkness, they give up some of that precision in exchange for raw sensitivity. If you could see your own eyes under infrared light at night, you'd notice they look different, wider, softer, almost searching. They're built to adapt, to give you the best chance of detecting even the faintest glimmer. There's something remarkable about this, that your body, without your conscious effort, is shaping itself to meet the universe halfway. You're not just a passive observer, you're an active participant in the exchange of light. And maybe knowing that, you'll never think of your eyes as static again. They are quiet instruments, tuning themselves for the oldest concert in existence, the faintest galaxy you might ever see. On a truly dark night, far from any artificial light, your eyes might just catch something extraordinary, a galaxy beyond our own. Not in sharp detail, not like the photographs you've seen, but as a faint misty smudge hanging in the dark. For many in the northern hemisphere, this would be the Andromeda Galaxy, the closest spiral galaxy to the Milky Way and the farthest object visible to the naked eye. Its light has been travelling for over 2 million years just to arrive at your gaze tonight. When you first spot it, you may doubt it's really there. It doesn't stand out like a star. It's softer, more delicate, almost like a breath in the dark. You might think you imagined it, until you look again and find it still waiting for you. There's something humbling about knowing that this faint patch is a vast city of 1 trillion stars, and yet your eye receives it with no more effort than catching the glow of a match in the distance. And in that moment, the scale of far takes on a new meaning, one that no map could ever explain. When your vision meets its edge, every sense we have has a limit, a point where it simply can't reach farther. For your vision, that limit comes quietly. You don't feel it arrive. You simply notice there's nothing more appearing, no matter how long you stare. That's the edge. Beyond it, the light is either too faint or too distant to trigger a response in your eyes. Telescopes can push past it, but for unaided sight, this is the boundary where the universe turns invisible. It's strange to think that the photons from a star or galaxy might still be striking your eye, but in numbers too small for your brain to register. The information is there, but it never becomes vision. Standing at this edge can feel both frustrating and awe-inspiring. Frustrating because you want more. Awe-inspiring because you've already reached farther than most creatures on Earth ever could. And it makes you wonder, how much of reality is just beyond the edge of what we can sense, quietly existing whether we see it or not? Why the moon feels closer than it is. When you look at the moon, it doesn't feel impossibly far away. It feels present, almost within reach. That's an illusion born from brightness and detail. The moon reflects so much sunlight and shows such sharp features to the naked eye that our minds treat it as near. In reality, it's about 384,000 kilometers away, a distance you could circle the Earth nearly 10 times before matching. And yet, on a clear night, it can feel as though you could stretch out your hand and touch its rim. This closeness is partly because your eyes evolved to judge distance on Earth, not in space. The moon offers familiar cues, shadows, texture, crisp edges, and your brain mistakes those for proximity. That's why eclipses and rising moons feel so striking. Your mind is playing with scale, showing you a neighbour in the sky as if it were just over the next hill. And perhaps that's why the moon holds such power over us. It feels like a bridge between Earth and the unreachable, the trick of size in the distance. If you've ever seen a star low on the horizon look bigger than one overhead, you've met another of the sky's illusions. In truth, stars don't change size, but the atmosphere and our perception bend reality just enough to make them seem to swell or shrink. This trick of size happens because our brains interpret objects against their surroundings. Near the horizon, a star has trees, buildings, or mountains to compare to, and that contrast makes it seem larger. Overhead, with nothing but empty sky around it, it shrinks back to a pin. Astronomers call this the moon illusion when it happens with our lunar neighbour. It's not that the moon changes, it's that our minds can't help reshaping the scene to fit our sense of scale. In a way, the night sky is a constant reminder that what we see is filtered through perception. We're not receiving a raw picture of the universe. We're receiving our brain's best guess. And maybe that's part of why stargazing is so personal. Each person's guess is a little different. The shimmer of a faraway sun. Every star in the night sky is a sun, some smaller, some much larger, all unimaginably far away. And yet, even from such distances, their light still finds you, shimmering through the veil of Earth's air. This shimmer, that delicate flicker, is a gift of our atmosphere, bending and warping the starlight as it arrives. In the cold stillness of winter nights, when the air is steadier, the shimmer softens, and stars seem almost like jewels frozen in place. In summer heat, they tremble more, as if alive. If you've ever stared long enough at one bright star, you might notice flashes of colour, tiny shifts from blue to white to red. That's the atmosphere again, scattering wavelengths unevenly in a miniature, ever-changing rainbow. It's incredible to think that every one of these distant suns is lighting entire worlds we can't yet see. Some of those worlds may be barren, others may have oceans, and some might even have skies where other beings watch our sun shimmer. And as we open more of this night together, we'll find that the farther our eyes try to reach, the more they invite the mind to imagine what lies beyond. Stars whose light began before Earth formed. It's a strange feeling, knowing that some of the light you see tonight began its journey before Earth even existed. There are stars so ancient that, when their photons left home, the Sun had not yet been born, and our planet was still only a possibility in a cloud of gas and dust. These stars are often found in globular clusters, dense, spherical swarms of stars that orbit the edges of our galaxy. Many are over 12 billion years old, which means their light has been travelling for billions of years before finding your eyes this evening. When you think about that, you realise you're not just looking across space. You're looking across deep time. Your vision becomes a time machine, quietly collapsing billions of years into a single glance. And the thought sneaks in, if the universe can hold a memory that long, what else might it be remembering? The boundary where your eye surrenders to instruments. There's a point where human sight reaches its limit and can go no farther. Beyond it, the night still spills light toward us, but it's too faint for even the best adapted eyes. This is where instruments, telescopes, cameras take over. A small backyard telescope can show you details you'd never see otherwise. The moons of Jupiter, the rings of Saturn, the mist of distant nebulae. Professional observatories go far deeper, revealing galaxies that would remain invisible for all of human history without their help. It's a reminder that our senses are powerful, but they are not complete. Technology doesn't just extend them, it reshapes them, showing us a universe that has always been there, waiting for us to build the tools to meet it. And yet, there's something beautiful about knowing that even without any device, your unaided eye can still catch a galaxy 2 million light-years away. It means that, at least a little, you're already built for this. How ancient eyes once mapped the heavens. Long before telescopes, long before science as we know it, humans studied the night sky with nothing but their eyes. They learned to track the movement of planets, the cycle of the moon, and the slow drift of constellations from season to season. In some cultures, these patterns were stories, myths written in light. In others, they were calendars, helping farmers know when to plant or sailors when to set sail. Without paper or instruments, the sky itself became the archive of knowledge. What's remarkable is how accurate those ancient sky maps were. With no technology beyond patience and memory, observers could record positions to a degree that still impresses modern astronomers. It's a reminder that the human eye is not just a passive organ. It's a tool for pattern and meaning, and it has been our guide in navigating both the Earth and the cosmos. The myths born from distant lights. Every culture has looked at the stars and imagined stories into them. A hunter chasing prey across the sky, a goddess guarding a river of light, a trickster stealing fire from the heavens. These myths are as old as language itself. The stars offered a canvas, and humans painted their fears, hopes, and morals onto it. Some saw omens in a bright comet. Others believed a new star meant the birth of a great leader. The heavens became both map and mirror. Even today, those old stories linger in the names of constellations and planets. Orion, Andromeda, Venus, each is a fragment of a much older tale whispered across generations. And perhaps part of the reason we still look up is that we're all, in some way, still trying to read those stories. When planets join the dance of night, most of the points of light you see are stars, but a few are planets. They don't twinkle the way stars do, because they're close enough for their light to be more stable through our atmosphere. And when one appears in the evening sky, it often becomes a silent focal point. Venus can blaze so bright it's mistaken for a UFO. Jupiter can outshine every star in the sky. Mars, in its close approaches, glows with a rusty fire that even city lights can't drown out. Watching planets is different from watching stars. They move against the fixed patterns of constellations, shifting night to night. This slow dance is how ancient astronomers first realized they were different kinds of objects entirely. There's something grounding in knowing that, while most of the lights above are impossibly far away, a handful are neighbors, worlds sharing the same sun, just on different paths. And as we open more of the sky tonight, we'll find that even the faintest colors and movements tell us more about how far our eyes can really reach. The hidden colors of starlight. Every star you see is a palette of colors, even if your eyes can't always tell. Under the right conditions, bright stars reveal themselves in subtle shades: blue-white like Sirius, golden like Capella, deep orange like Betelgeuse. Each hue tells a story about temperature, age, and even chemical makeup. In daylight, your eyes are experts at color, but at night, they're cautious, holding back unless the light is strong enough. That's why faint stars look white, even though they're not. Your rods take over in the darkness, trading color sensitivity for raw light gathering. Yet for those who know how to look, even a faint tint can be thrilling. It's like catching a whispered word in a quiet room, proof that there's more being said than you can easily hear. And once you've noticed a star's color, it's hard to unsee it. Every time you meet it again, you'll remember that hidden richness, waiting to be noticed. How some stars appear brighter than they truly are. Brightness in the sky is a trickster. A star might appear brilliant simply because it's close, while a far more powerful star looks faint because of distance. Our eyes can't judge those distances, they just report the light as it arrives. This is why Alpha Centauri, our closest stellar neighbour, shines so clearly, while Deneb, thousands of light years away but far more luminous, appears as only a modest point. The scale of space hides its giants in plain sight. It's humbling to think that what you see is not an equal playing field. Brightness is not always strength, and faintness is not weakness. It's often just distance speaking. That truth changes how you see the sky. It reminds you that appearances are only part of the story, and the real scale of things is always larger than your senses suggest. The illusion of twinkling. To your eyes, stars twinkle, a tiny shimmer, a restless sparkle. But in truth, they shine steadily. The twinkling happens in their last moments of travel, as their light passes through layers of Earth's moving atmosphere. Hot and cold air mix, bending the light in constantly shifting ways. It's like looking at an object at the bottom of a rippling pool. The image moves, changes, wavers, even though the object itself is still. Planets, being closer and appearing as tiny disks rather than points, usually escape this twinkling. That's one way to tell them apart from stars: a steady glow in a restless sky. It's strange to realize that this shimmering, which makes the night seem alive, is actually a kind of distortion. And yet without it, the sky might feel less magical. Imperfection has its own beauty. What happens when starlight touches your retina? Every star you see begins with a particle of light, a photon, striking the back of your eye. It's such a small event that it's almost absurd to think about. One tiny particle, travelling across vast emptiness, ending its journey in a fraction of a second. Your retina contains cells called rods and cones, and when a photon hits one, it triggers a chemical reaction. That reaction becomes an electrical signal, racing to your brain, where it's turned into an image. In other words, your mind is constantly painting a picture from ancient arrivals. It's almost ceremonial. The universe sends its light, and your body receives it, transforms it, and briefly holds it in awareness before letting it go. And every second, millions of these tiny exchanges are happening without you noticing. Once you know this, it's hard not to feel a sense of intimacy with the night sky. You're not just looking at it, you're physically connected to it, one photon at a time, the tiny spark that becomes a memory. Some of those photons you catch will stay with you forever, not in your eyes, but in your mind. You'll remember the night you saw a meteor flash across the sky, or the first time you noticed the glow of a far-off galaxy. Those moments begin as light and end as memory. It's a strange kind of alchemy, turning something physical into something emotional. A tiny particle from a star becomes part of your personal history. And memories of the night sky tend to age well. They don't fade like other recollections, maybe because they feel bigger than you, or because they're tied to the rare moments when you truly stopped and looked. Every time you think back to them, you're holding that spark again, if only for a moment. And perhaps that's how the stars stay alive in us, not just as light, but as the stories we tell ourselves about the times we met them. And as we open more of this journey, the patience of light will start to show us just how much of the universe has been waiting, quietly, for our eyes to arrive. The patience of light in a cosmic journey. Light never rushes, yet it is never late. When a photon leaves the surface of a distant star, it begins a journey that will not be interrupted. No pauses, no rests, just steady travel across an emptiness so vast that human maps become meaningless. Some of this light will pass worlds, some will slip past entire galaxies, and some will wander for millions of years before arriving here, tonight, to fall quietly into your eyes. It's humbling to realize that in the time it took that light to reach you, entire civilizations could have risen and vanished on distant worlds. Stars could have been born, lived and died, and still, the light that began before those changes continues forward, as if nothing could dissuade it from completing its path. This patience is unlike anything we experience on Earth, where even mountains wear away with time. On Earth, we measure journeys in hours, days, or years. But in space, journeys can span hundreds of millions of years, and yet, when they end, the arrival is as gentle as a whisper. That is the strange beauty of light. It travels unfathomable distances only to dissolve quietly into the awareness of someone who happens to be looking up. Sometimes I think about how many photons miss us entirely, slipping by Earth in the night without ever touching our eyes. They continue onward, carrying their message, perhaps to be caught by another set of eyes somewhere else in the universe. In that way, stargazing feels almost like luck, a rare interception of something that could have passed you by forever. And maybe that's why, when you stand under a clear night sky, you can feel both small and profoundly connected. You are not chasing the light has found you, and somewhere, in the patience of its journey, there is a quiet reminder that some things are worth the wait. Why some light is older than humanity. Some of the light you see tonight began long before there were people to see it, before the first human story was told, before even the first human step. These photons left their homes when our planet was still wild, untouched by language, cities, or thought. And now they arrive, unchanged, except for the long stretch of space and time they have crossed. When we look at a bright nearby star, the light might only be a few years old. But with fainter, more distant stars, or galaxies beyond, that light can be thousands, millions, or even billions of years old. It is ancient not just by our standards, but by any measure we can imagine. And yet, it is still active, still capable of sparking vision in an eye tonight. There is something quietly moving about that. This light has seen things we cannot fathom, the slow drift of galaxies, the birth of suns, the silent collapse of others. It has travelled through cosmic dust, around invisible dark matter, across gulfs where almost nothing exists. And through all of that, it has remained pure, carrying with it the exact same energy it had when it began. When we say we are looking into the past, it's not just a poetic idea, it's literal. The starlight you see is a time capsule. To look at a star 10,000 light years away is to look at it as it was 10,000 years ago, before pyramids, before metal, before much of what we think of as history. It makes you wonder, how much of what we see above us is already gone? How many stars have faded or changed in the time since their light left, leaving us to see only their ghost in the present moment? The night sky becomes not just a map of space, but a memory of time itself. How the Andromeda Galaxy greets the naked eye. On the clearest nights, when the air is still and the world below is dark, a soft smudge appears in the sky, faint, barely there, and easy to miss if you don't know where to look. This is the Andromeda Galaxy, the nearest spiral galaxy to our own, and the farthest object you can see without a telescope. At first glance, you might mistake it for a patch of cloud, or perhaps think your eyes are playing tricks. But once you notice it, it doesn't vanish. It lingers there, patient and pale, as if it knows it has travelled far enough to deserve your attention. And when you remember that its light began more than 2 million years ago, the faintness of its glow feels like an understatement. Andromeda contains 1 trillion stars, more than our Milky Way. Yet to your eyes, unaided, it is just a blur, a ghostly island in a sea of black. That's because most of its light is too faint for us to register. We catch only the brightest parts, leaving the rest hidden in the dark, waiting for instruments to reveal them. The idea that you can see another galaxy with nothing but your own eyes is one of the great wonders of stargazing. It means that your vision, which evolved to spot movement in grass and find berries in bushes, is also capable of touching the edges of the cosmos. That's a leap no other sense can quite match. And maybe that's why, when you find Andromeda, you linger. You let your eyes rest on it longer than necessary, because somewhere in that tiny smudge is the quiet realization that the universe is both bigger and closer than you ever imagined. The faint haze of far-off clusters. While galaxies are grand, star clusters are more intimate, gatherings of suns bound together by gravity. Some clusters are close enough to see clearly through binoculars, or even with the naked eye as a faint blur. Others are so far away that they appear only as a soft haze, blending into the background of night. When you spot one of these hazes, you're not looking at a single star. You're looking at hundreds, sometimes thousands, of stars packed into a small space from our perspective. In reality, they may be light years apart, but their distance from Earth compresses them into a single shimmering patch. Globular clusters, for instance, hang like ancient lanterns in the halo of our galaxy. They are among the oldest objects in the universe, containing stars that have burned for more than 12 billion years. The light from these clusters is faint but persistent, a sign of their incredible age and stability. Seeing them with the naked eye takes effort. A dark sky, patience, and sometimes a bit of averted vision. But when you find one, there's a strange satisfaction in knowing you're looking at a relic of the universe's earliest days, still glowing in the deep. And maybe that's the gift of these hazy clusters. They don't shout for attention. They reward the quiet observer, the one willing to stand still long enough for the faintest lights to find them. Seeing the edge of our galactic home. From Earth, we live inside the Milky Way, which means we can't see it from the outside. But on the darkest nights, away from artificial light, we can trace its shape. A pale, luminous band stretching across the sky. This is the view from within, the edge-on perspective of our own galaxy's disk. What you're seeing is not a single object, but billions of stars whose light blends together into a soft glow. Dark lanes of interstellar dust weave through it, hiding parts of the galaxy from view. These shadows give the Milky Way its texture, its almost smoky appearance in the night. It's a view that has inspired countless myths and stories. Some saw it as a river, others as a pathway for souls, others still as a bridge between realms. And even today, standing beneath it can feel like standing under a cosmic roof, with the rest of the universe stretching out beyond its edge. The realization that you're looking through the dense center of your galactic home changes how you think of up and down. There's no real up here, only in, out, and across. You are inside something so vast that the idea of leaving it is almost impossible to grasp. And yet, when you stare at the Milky Way, you can't help but wonder, what does it look like from the outside? What would it be like to stand in another galaxy and see our own as just a faint band in their night sky? That quiet question is what keeps us looking. How dust hides the stars we can't reach. When you look at the night sky, it's easy to think that the dark spaces are just emptiness, the places where there are no stars. But often that darkness is not the absence of light, it's the presence of dust. Not the dust on your shelves, but cosmic dust. Tiny grains of rock, carbon, and ice drifting between stars, thick enough to block their light. These dust clouds can stretch for hundreds of light years, hiding entire clusters of stars from view. To the naked eye, they appear as gaps in the Milky Way, strange patches where the river of light is interrupted. In truth, the stars are still there, burning brightly, but their glow never makes it to us. The effect is a little like looking at a city skyline through heavy fog. You know the buildings are there, but their outlines blur and fade into the haze. Only here, the fog can last for millions of years, slowly shifting as stars are born within it or drift away from it. Astronomers use instruments that can see in infrared light to peer through this dust. To those eyes, the dark patches light up with hidden suns, newborn stars still wrapped in the clouds from which they formed. But without such tools, we are left with mystery. And perhaps that's not such a bad thing, because those dark lanes give the Milky Way its depth, its texture, its drama. They remind us that not everything is meant to be seen at once. Some parts of the universe keep their secrets, at least until we're ready to find them. The farthest human eye has ever claimed to see. Under the very best conditions, the highest mountaintops, the clearest air, the darkest nights, some observers claim to have seen objects so faint and distant they brush the true limit of human sight. One famous example is the Triangulum Galaxy, about 3 million light-years away, just barely visible as a tiny smudge to the sharpest eyes. Seeing something like that without a telescope is not easy. It requires patience, perfect weather, and eyes fully adapted to darkness. Often you have to look slightly away from the object, using your peripheral vision where your eyes are most sensitive to faint light. Even then, it may appear and vanish, a ghost playing on the edge of awareness. There are even rare reports of people seeing the bright core of certain galaxies or nebulae far beyond what most could manage, especially during moments of exceptional atmospheric clarity. Whether all such claims are accurate is hard to prove, but they speak to the incredible potential of human vision when all conditions align. It's worth noting that your eyes are not just passive receivers in this. Your brain is actively helping, filling in and amplifying signals to make sense of the faint light it gets. Sometimes that means you see something that's more an impression than a sharp image, but in astronomy, impressions still matter. And perhaps that's the beauty of this edge of vision. It's where science and wonder meet. The point where we're not entirely sure if we're seeing with our eyes, our minds, or both. When the Milky Way spills across the night, if you've ever been far from city lights, you know what it feels like to look up and see the Milky Way in full. It's not a thin streak, it's a wide, luminous river pouring across the sky, rich with detail and texture. It feels less like something above you and more like something you're inside. The first thing you notice is how uneven it is. Some areas are thick with light, almost cloud-like, while others are cut with dark, twisting lanes. You might even see color, faint blues or yellows in the brightest regions. And as your eyes adjust, more and more stars appear until you realize you're looking at a depth that can't be counted. This sight is a reminder that our galaxy is not just an abstract idea, it's a real physical place, and we live inside its glowing disk. Every star in that ribbon belongs to the same sprawling family of suns, bound together by gravity, spinning slowly in space. To think that each point of light in that river is its own world, maybe with planets, maybe with life, is almost too much to hold at once. And yet the Milky Way makes it feel possible, as if the universe is inviting you to imagine it. It's easy to understand why ancient people called it the path of the gods, or the spilled milk of creation. Under a sky like that, you don't just see stars, you feel them, why your eyes can't see the Hubble Deep Field. One of the most famous images in astronomy is the Hubble Deep Field, a tiny patch of sky that, when photographed with a space telescope, reveals thousands of distant galaxies. But here's the humbling truth. If you stood under the darkest night sky and looked at that same patch with your eyes, you'd see nothing, not a single galaxy. The light from those galaxies is real, but it's far too faint for the human eye to detect. Hubble captured it by staring at that spot for over 10 days, collecting every last photon until a picture emerged. Your eyes, by contrast, refresh their image many times a second. They can't stack light in the same way. It's a reminder of just how much the universe hides from us, and how much technology has expanded our vision. Without telescopes, we'd never know that every square inch of the night sky is filled with galaxies, each containing billions of stars. And yet, there's something quietly beautiful in the idea that we don't see it all. The blackness between stars isn't empty, it's just beyond us for now. And maybe, in a way, that makes the few things we can see feel more precious. It's a gentle limit, not a punishment, an invitation to keep building better ways of looking. How telescopes extend our sight. When your eyes reach their limit, a telescope is like a second chance. It gathers more light than your pupils ever could, pulling in faint objects and making them clear. Even a small backyard telescope can reveal things your naked eye will never meet. The moons of Jupiter, Saturn's rings, the delicate shape of a distant nebula. The magic lies in its simplicity. A telescope is essentially a bucket for light, collecting it and focusing it into your eyes. The bigger the bucket, the more light it gathers and the farther you can see. It doesn't make things brighter by magic, it simply gives you more of what's already there. Through a telescope, the universe becomes layered. The bright, familiar stars are joined by new companions, clusters, galaxies, faint smears of light that might be entire universes on their own. You realize quickly that the sky you thought you knew is only the beginning. And yet, even with all this extra reach, the feeling is still the same as with the naked eye. You're catching light that has traveled impossibly far through empty space to meet you. The telescope just makes the meeting easier. Perhaps that's why people who look through a telescope for the first time often gasp or laugh or fall quiet. It's not just the detail that moves them, it's the sudden awareness that the universe is right there, waiting, if only we're willing to look deeper. The thin line between seeing and imagining. When you stare at the night sky long enough, something curious happens. You start to see things on the edge of perception. A faint smudge here, a flicker there. Sometimes they're real, and sometimes they're creations of your mind. The line between seeing and imagining is thin in the dark. Your brain is not a camera. It doesn't simply record light. It interprets it, fills in gaps, and tries to make sense of incomplete signals. In daylight, this helps you recognize a friend in a crowd or a shape in the distance. But at night, under the stars, it can lead to delicate illusions. You might think you see a faint star that disappears when you look directly at it, or a pattern in the Milky Way that changes when your eyes shift. These moments aren't failures, they're proof that seeing is a partnership between eye and mind. The eye delivers what it can, and the brain adds what it thinks should be there. Astronomers call this averted vision when deliberate, using the more sensitive edges of your sight to detect faint light. But there's also an unconscious version where your mind takes a fragment of light and completes it into a fuller image. It's a little like dreaming while awake, and maybe that's the magic of stargazing. You're never just seeing what's there. You're seeing what's there, plus what your mind quietly builds around it. The sky isn't just overhead, it's also inside you. When your mind fills in the cosmic gaps, our eyes have blind spots, literal ones where the optic nerve meets the retina, and broader ones where light is too faint to detect. But the brain is reluctant to leave gaps. It fills them in with context, memory, and assumption. Under the stars, this filling in can be almost artistic. Look long enough at a cluster of faint points, and you might start to see extra stars that aren't truly visible. Your brain extends patterns, making constellations richer, shapes more distinct. This is part of why ancient people could see animals, heroes, and rivers in the sky. Their minds weren't just reading the stars, they were painting between them. Sometimes this means a galaxy or nebula appears bigger than it really is to your eye. You catch the bright central part, but your brain subtly extends the glow outward, giving you a sense of its true size without the detail. In a way, you're collaborating with the universe to create the picture. This partnership is why stargazing feels so deeply personal. No two people see the exact same thing, even under identical conditions. The sky is fixed, but the mind's additions make it unique for each observer. And perhaps that's the quiet truth. We don't just observe the cosmos, we co-create our experience of it. The rhythm of looking and blinking. It's something you don't often think about, how often you blink. But when you're stargazing, the rhythm changes. You hold your gaze longer, keeping your eyes open for a few extra seconds, as if afraid the stars might slip away while you blink. This longer stare lets more photons gather in your vision before your eyes reset. It's not much, just fractions of a second more light, but under the faintest conditions, it can make the difference between seeing something and missing it. That's why astronomers often talk about catching a glimpse of a faint object. Blinking, though, is not your enemy. In fact, it can help. A quick blink refreshes your eyes, clears minor dryness, and can sometimes make a dim star pop out again. There's a balance. Too much staring, and your eyes tire. Too much blinking, and you break the flow of light. It's a small reminder that stargazing isn't just a mental act. Your whole body participates. Posture, breath, even the way you open, and maybe that's why time under the stars feels slower. Your natural rhythms shift, matching the unhurried pace of the sky. How eyes strain to hold onto a faint star. When you spot a very faint star, it can feel fragile, like it might vanish if you move even slightly. And sometimes it does. Your eyes strain without you realizing it, tiny muscles adjusting to keep that point of light in view. This strain is subtle but real. In dim conditions, your eyes work harder to focus, especially on small points. Your pupils are wide, letting in more light, but that also reduces depth of field, meaning focus is harder to maintain. You're balancing at the edge of what your vision can manage. The odd thing is, the more you try to force it, the more likely you are to lose it. A relaxed gaze, sometimes slightly off to the side, often works better. This is why seasoned stargazers talk about soft eyes, a way of looking without locking on too tightly. Holding a faint star in sight can feel like balancing a thought. Too much effort, and it slips away. too little, and it fades into the dark. It's an exercise in patience, not power. And when you succeed, there's a quiet triumph in it, a shared moment between you and a piece of the universe that only just agreed to be seen. The glow that fades when you look straight at it. If you've ever noticed a faint glow in the corner of your vision, only for it to vanish when you look directly at it, you've met one of the quirks of human sight. This happens because the central part of your retina, packed with cones for color and detail, is less sensitive to dim light than the rod-rich areas around it. When you look straight at a faint star or nebula, the light falls on that less sensitive central zone and the object can disappear. Look slightly to the side and the light lands on rods instead. And suddenly, the object reappears. This is the principle behind averted vision. It's counterintuitive because we're taught to look directly at things we want to see clearly. But under the stars, direct gaze can betray you. Sometimes looking away is the only way to see. The effect is even stronger for extended objects, like nebulae or galaxies, which are already faint and diffuse. They often appear brighter and more detailed in peripheral vision, even though you can't focus on them directly. And maybe there's something poetic in that. Some truths are clearest when you're not staring straight at them, but holding them gently at the edge of awareness. The faintest colours we lose in night skies. In daylight, colour is everywhere. Leaves in green, bricks in red, the sky in blue. But at night, the world drains of its palette. Even the stars, which burn in rich shades from orange to blue, often look white to the naked eye. This isn't because their colours vanish, it's because your eyes surrender them. In darkness, your cone cells, the ones responsible for colour, become far less active. Rod cells, which take over for dim light, are far more sensitive to brightness, but almost blind to colour. It's a trade your eyes make, sacrificing richness of hue in exchange for the ability to see faint light at all. This is why, under a truly dark sky, only the brightest stars show their colour. Betelgeuse with its deep amber glow, Rigel in icy blue, Mars in dusty red. The rest are stripped to their raw light, their spectrum invisible until you view them through a telescope. Astronomers sometimes use a trick to reveal these faint colours, looking slightly to the side of a star to catch it with the more sensitive parts of the eye, then switching back quickly to the centre to notice the brief flash of colour before it fades. It's fleeting, but magical, a glimpse of something usually hidden. And perhaps that's why, when you do see a star's true colour, you remember it. It feels like the sky briefly leaned closer, showing you something it keeps from most. How airglow hides the true black of space. Even under the darkest night sky, the heavens are never completely black. There is always a faint background glow, a soft veil called airglow. It's caused by chemical reactions in the upper atmosphere, where molecules excited by sunlight during the day slowly release that energy at night. Airglow is usually invisible to the casual stargazer, but it's always there, tinting the sky with the faintest green or red light, especially when captured in long exposure photographs. It's the Earth's own quiet light show, a reminder that even in stillness, our atmosphere is alive. For astronomers, airglow is both a beauty and a challenge. It gives the night a subtle shimmer, but it also makes the sky slightly brighter, hiding the faintest galaxies from view without special equipment. It's why observatories are often built in remote, high-altitude locations. Not just to escape city lights, but to rise above more of this atmospheric glow. If you could step outside the Earth's atmosphere entirely, space would be darker than anything you've ever seen. So dark it would almost feel like a physical presence. But here on the ground, airglow wraps us in a thin, luminous blanket. And maybe that's comforting. Even in the deepest night, the Earth is still quietly shining back at the universe. the strange limits of daylight astronomy. It feels natural to think of astronomy as a nighttime pursuit, but the truth is, the sky doesn't stop existing when the sun rises. Stars are still there. They're just drowned in the brilliance of daylight. Our eyes can't compete with the overwhelming flood of sunlight scattering in the atmosphere. Yet with the right conditions, a few celestial objects can be seen even in the day. The moon, of course, is often visible against the blue. Venus, at its brightest, can sometimes be spotted with the naked eye if you know exactly where to look. And for those with telescopes and careful technique, brighter stars like Sirius can be found in daylight too. The difficulty lies in contrast. At night, stars shine against darkness. In the day, they're competing with a glowing sky. Your pupils stay small in daylight, reducing light intake even further. It's less about the star not being there, and more about our vision being tuned for the sun's dominance. Daytime astronomy is a reminder of how much our environment shapes our senses. We don't see less in the day because the stars vanish. We see less because our eyes are built to prioritize survival in bright conditions. And perhaps that's why night feels so magical. It's the rare time when the universe has the stage all to itself. Why Venus can outshine everything but the sun and moon. Venus is often called the evening star or the morning star, though it's neither. It's a planet wrapped in thick clouds that reflect sunlight with incredible efficiency. This high reflectivity, combined with its proximity to Earth, makes it brighter than any star in the sky. When Venus is at its peak, it can cast shadows, even though it's millions of kilometers away. It's so bright that in dark, rural areas, it almost feels unnatural, as if a light bulb had been hung in the heavens. No wonder ancient cultures saw it as an omen, a goddess, or a herald of change. Part of Venus's brilliance comes from its size in our sky, much larger than a star's pinpoint, so more light reaches our eyes. And unlike stars, which twinkle in atmospheric turbulence, Venus shines with a steady, almost unblinking light. If you've ever seen it in daylight, a rare but possible sight, you'll understand why it has inspired so much fascination. It feels wrong to see a star in a bright blue sky, and yet there it is, refusing to be hidden. And maybe that's the essence of Venus's allure. It reminds us that not all wonders wait for darkness. How comets catch the corner of your eye. Comets are rare visitors, and when they appear, they often do so quietly at first, a faint blur that you might notice in your peripheral vision before you spot it head-on. This is because their light is diffuse, spread across their glowing coma and tail, making them easier to catch with the rods of your eye than with the cones at its center. When a comet brightens enough to be visible without a telescope, it feels like a personal gift from the cosmos. Its tail, streaming away from the sun, can stretch across the sky, yet remain delicate, almost ghostly. And unlike planets or stars, comets move. Night by night, their position shifts against the backdrop of constellations. This motion gives them a sense of life, of fleeting presence. Ancient peoples often saw comets as harbingers, their sudden, unpredictable arrivals breaking the steady rhythm of the heavens. Today, we understand their icy origins, but they still carry that feeling of rarity and mystery. To see one with your own eyes is to witness something transient on a cosmic scale. It's not just starlight you're catching, it's a traveller from the outer edges of the solar system, swinging by before vanishing for decades, centuries, or even millennia. And perhaps that's why comets linger in memory. You don't just remember the sight. You remember knowing that in all your life you may never see that same one again.